Our second to last topic in this math sort of intro to chemistry is temperature conversion. So we are going to talk about temperature and temperature change. And so the units for temperature, the metric units would be Celsius or Kelvin, so degrees Celsius or degrees Kelvin. Now there is the imperial system of Fahrenheit, which you might be familiar with. Again, our textbook is American, and so it gives probably a little more play to Fahrenheit in these temperature conversions than we would in Canada, because we don't measure things often in Fahrenheit. Sometimes I know things in Fahrenheit that I don't know in Celsius, like body temperature, and I remember when my oldest had a fever for the first time, I realized that the thermometer I had was in Celsius, and my panicked mind didn't realize there was a button to push to change it into Fahrenheit. But I know what it means or how it feels to have 101 degree Fahrenheit temperature. I don't know what that is in Celsius. And so when the panic went away, I realized there was a button that could switch my thermometer back and forth, but this idea of doing temperature conversions would have been helpful for my panicked self. And so just spending a little bit of time on these different scales, if you will. Celsius scale built on the properties of water. So water freezes at 0 degrees Celsius and boils at 100 degrees Celsius. The degree in Celsius is the same size as the degree in Kelvin. So these are both metric. And so they have that equivalent size of a degree. The only thing that's different between the Celsius and the Kelvin scales is their 0. And so they are offset by 273 degrees Kelvin. And the reason that they are offset by 273 degrees Kelvin is that the Kelvin scale is built on the idea of absolute 0. So the absolute 0 is way down here on the Kelvin scale, and that is almost theoretical in its understanding. It's if we could get something so cold that we stop all atomic or molecular movement. It's impossible to imagine almost, but that's what the absolute 0, way the heck down here on the Kelvin scale is. And so it's the absolute temperature scale. It begins at absolute 0 and has only positive values. It's offset, like I had said, by 273 degrees Kelvin because they are equivalent. So 0 degrees Celsius is 273 degrees Kelvin. If we go to the imperial measurement scale, the Fahrenheit, they have smaller degrees. So it's actually a fraction of a degree Celsius is a degree Fahrenheit, which makes things a little bit complicated and makes our conversion a little bit different. There's lots of information out there about the evolution of these temperature scales, but we're going to move on and take a look at how you could convert. And so these conversions are on your formula pages, again, not needing to memorize them. It's really simple going within the metric system because they are just offset by that 273 degrees. Going from metric to imperial of lesser use, but maybe you need to understand a forecast in Seattle or something like that, or your child has a fever and you don't know what the Celsius thermometer is telling you. Yeah, so these ones can be useful. And again, these formulas don't need to be memorized. They're on your formula pages. So let's take a look at these ones. Again, these can kind of illustrate some problem solving. So we would like to figure out what this temperature is on the Celsius scale. So temperature in Celsius would equal the temperature in kelvins minus the 273. So the temperature in kelvins is 77. So I'm going to substitute in what I know and then just follow the instructions, do the math. I get down to negative 196 degrees Celsius. Now, I rounded that to the nearest whole number. This one you would be subtracting, and so you'd follow the rules of the least decimal places or the place values and round it as such. And it's kind of a rigged question because there was a 0 there, so if you put the decimal, I probably wouldn't mark you wrong, but technically you should round to the nearest whole number. So the next one, water freezes at 0 degrees Celsius. What's the freezing point in kelvins? And you might be able to just know this, but again, this is all about developing strategies for figuring out and problem solving. And so we would like the temperature in kelvins when we know the temperature in Celsius. So temperature in kelvins is temperature in Celsius plus that 273. So I would sub in what I know as 0 degrees Celsius plus the 273. And the temperature in kelvins is 273 degrees Kelvin. One last one, and again, just modeling, using these formulas, not really doing any algebra here. This one says that we know our temperature in Fahrenheit. What is the temperature in Celsius? And so this would be the formula right here that I would use. My temperature in Celsius would equal my temperature in Fahrenheit, minus 32 all over 1.80. And so I would sub in my negative 40 and divide it. And lo and behold, this is the point where those two scales actually equal each other. So if it's really cold, here it's really cold there, and they are both minus 40. So minus 40 degrees Fahrenheit is the same as minus 40 degrees Celsius. That's where the two scales kind of even out with their different size of a degree of temperature.